1.7, applications using linear equations. Applications just means we're looking at word problems. And yes, as math people, we say real life word problems. Well, I mean, I don't know a lot of people that buy, 84 watermelons or something like that. But whatever it is, it's supposed to be applicable. You can decide if it is or not for you. Now, with these word problems, though, okay, of course, you got to read the problem. Now, I say that out loud, but I am guilty of skipping over a lot of the words and just kind of solving it because I'm lazy that way, all right? But try not to skip over the reading part of the problem, right? Like I'll look for keywords, and sometimes with math, especially math people, right? We try to trick people into doing the wrong thing. I try not to, by the way, but we do, okay? We try to trick people into doing the wrong thing on purpose, and we get a big kick out of it. I've heard math people, teachers specifically, we laugh at students. I should say they do, because I try not to anymore. But in any case, so in any case, do read the problems, and in some cases, you just may have to read it several times. And by several, I mean like 7 or 8 times. Some students have come to me and they've been like, Sal, dude, I read this thing 8 or 9 times and I still don't understand it. Now, if that's you, just understand, you may have to read it then 15 or 20 times. Because for whatever reason it is, it's hard to make these connections with the words. But like too, it says organize the information. Well, if you don't understand what you're reading, then it's hard to organize that information, right? So it is possible you may have to do some guess and test type methods, which is a legitimate problem solving strategy. It says to write an equation. I mean, I would only do that if it required it, which it will on the homework. And then of course, solve and check, right? But in the end, it should kind of make sense. And I say that loosely because, sometimes, if you're buying 84 watermelons, what makes sense after that? I don't know, all right? Here's a table of some common translations. Is, or the same as, of course, that would be equals signs. Some or more than. There's more than this, of course. And if we encounter any, we'll cover them. I guess some of the main ones for operations here. Sum, that's an answer to a addition problem. Difference is subtraction. Product is multiplication. It's possible they may use like a quotient, which would be division, or even like if you divide it up equally, or just somewhere says it's a split equally or something like that. That would indicate that you're going to be using division. All right. So this is just a list. Is it a list that you can expect to see? I don't know. I don't think so. It just depends on the way the question is worded, right? But sum, difference, product, and like I said, probably quotient, those are ones that you should probably expect to see, okay? Translate the following verbal statement into an algebraic equation, then solve. So this has 2 parts to it, right? You got the equation that we're going to need, and then we actually do have to solve it. Now, it does say to use x for the variable. Usually with variables, it means that you can choose what letter you want to use, right? Some people, my name starts with J, so I like to use J's. I don't know. We're just going to use x because they told us to. All right, now let's read this. And again, if you need to read it several times, do it. But it says the difference of 5 times a number and 9 is 8 less than the number. Okay, so let's break this apart. The difference. Okay, difference indicates subtraction, right? So I'm going to put a subtraction sign here. What are we subtracting? 5 times a number and a 9. The and goes with the difference. So the and here is splitting the 2 things that we are subtracting, the difference. Well, that would be the first thing, 5 times a number, and they told us to use x for the number, so I'm going to write that as 5x. Like I said before, I believe on the homework you can put multiplication between there. I am not going to do that. Hopefully that's okay. And the second part of the subtraction is 9. So 5x, 5 times the number, and 9. There we go. Okay. Is, that is the word for equals. 8 less than the number. Okay, now, I didn't see this on the list that we just saw, but for subtraction, less than is one of the indirect statements, meaning that it changes the order. For example, if I told you, and I'll relate this to money, so hopefully it makes sense. If I said you had $3 less than $10, and I said, how much money do you have? No one would say 13, right? You definitely wouldn't say negative $7, because you'd say, well, I had $10. 3 less than that would be $7, right? 7 would be the answer. This is 8 less than the number, so we got to take the number. 8 less than the number, we got to take the number, and we got to do 8 less than that. So that's where you got to subtract 8, okay? So this is the actual equation that we need to solve right here. And just like we've seen before, we see x's on both sides, numbers on both sides, but we know using principles of equality that we can solve this. Okay? Now I want to emphasize this. If you put 8 minus x right here, you would solve it. You may solve it correctly with the correct principles of equality, but it would be incorrect because your original equation would be incorrect. And it would just be this part. 8 less than a number, that's what this reads right here, okay? So before, we talked about sometimes math is what you want it to be. I mean, I think we would all kind of prefer to see this initially, but sometimes verbally we have to be able to communicate this in different ways. I'm not saying that you're going to use this every day in your life, but here we go, okay? So now we got the equation, and I'll box it in later, but we got to solve this, okay? So, like I said before, I'm going to say, well, I'm going to put the x on the left, numbers on the right, because that's commonly what most students prefer to do, and just to save a little bit of time, because it is kind of a long lesson today, I'm going to do 2 steps in one phase right here, okay? So the minus 9, I got to zero that out because it's on the x side. It doesn't have an x. It's the non-x term, so I'd have to add 9 there, which means I'd have to add 9 to the other side as well, okay? So negative 9 plus 9, that does zero that out. And then on the right side, that's negative 8 plus 9, which is 1. Now, I'm going to take that x, this 1x right here in orange, and purple now, and I got to zero that out because it's on the number side of things. We don't want x terms where the numbers are, so we got to subtract the 1x, not only from one side, but both sides. 5x's minus 1x's would be 4x's. So now I get 4x's would equal 1. We don't want 4x's, we only want 1x's. So even though we've used 2 principles of equality, the last one we got to use is division, where we divide by the coefficient, which is 4. That makes the coefficient of x 1. Phantom 1x equals 1/4. And then, of course, we'll check, right? So that'd be 5 times, that's 5/4 minus 9, 36, 31/4, and then 1/4 minus 8. Maybe I'm doing that wrong. Checking my calculator. So yeah, just checking in the calculator, it checks off. Negative 31/4 on both sides here. And now I know that x equals 1/4 is the solution to that equation. But then again, there were 2 parts to this. Not only that x is 1/4 here, but the original equation that we had written. All right, same thing on this one. We'll write the statement, the equation, and then we will solve for x. And we'll use x for our variable, no problem. 3 times some number plus 1 is 7. What is the number? So that's just, solve for x right here. And so what does it say? It says 3 times some number. That's what we got to start out with. Well, that would be 3 times the number, which is x. We don't know what the number is, just some number, x. And it says plus. That's a pretty direct statement for addition right there. 1 plus 1. So there's plus 1. That would be 3 times some number plus 1, just as a statement right there, as a math expression. That's where our equal sign goes. Oh, this one's not too bad. 7. So this looks like one of those 2-step equations we did in 1.2, and we should be able to do this now with principles of equality. Of course, this is one of our solutions, right? At least for this type of problem that you'll see on the homework. But we do need to solve it. So here we go, principles of equality. I'll take that plus 1. I just want to zero it out because I want those 3 x's all by themselves. So I'm going to have to subtract 1 from both sides of the equal sign here, okay? That's our principle of equality. So that becomes 0. I'll drop my 3x, which now equals 7 minus 1, which is 6. This is going to turn out very nice. Divide both sides by 3. Why? To make that coefficient of x a phantom 1, right? So that ends up being x equals 2. And this one I think I can do in my head. 3 times 2 is 6, plus 1 equals 7. Yeah, that's true. That's a true statement right there. So x does equal 2. And then the original statement we had, or the equation we had there in the beginning, That would be the other answer for this type of problem. And same idea, we'll write the equation, then we'll solve for x. We'll force you to use x, no problem. 4 times the sum of double sum number plus 1 is 11. What is the number? Okay, well, let's just start out here. It says 4 times the sum of double sum number plus 1 is 11. So, and they kind of use the word sum here twice, right? Sum and plus. And we know that is addition. But notice here in the beginning, it says 4 times that sum. So we got to take that sum, and this comes back to the order of operations. We would have to take the sum and then multiply it by 4. 4 times the sum. So this is where you're going to see parentheses, and there really isn't, I mean, they can be worded slightly differently sometimes so that there would be no parentheses. In that case, it would be like 4 times the number, or the sum of 4 times the number and 1 or something like that, okay? But this one, it's 4 times the sum. If you see that, even if it said 4 times the difference, the only difference with that would be that you'd have subtraction there, okay? But you still have the parentheses. So it's 4 times the sum of what? Well, double sum number, so we got a double sum number, so that's double would be 2. Of course, if we saw triple, that'd be 3. I don't think they'd ever go as high as quadruple or higher, but double, okay? Plus 1. Okay, there's double sum number plus 1, and that's 4 times that sum right there is, so that's equal, is 11. Okay, so there we go. We got a nice equation going for us right there, and that's the equation that we need to solve for the number. And again, so you're going to have to type this in. You're going to have to use parentheses to type it in. But yeah, you're going to need those. All right, so this one has some distribution for us, no problem. We can work with distribution by distributing this 4 into the parentheses. 4 groups of 2 x's would be 8 x's. And then 4 groups of 1 would be 4, positive 4, by the way. So this still equals 11. All right, so we're down to a 2-step equation. Our x's are all on the left, so I don't want that plus 4 with it. So I'm going to zero that out by subtracting 4 from both sides. Zero that out just like it did. We'll drop the 8x, which now equals 11 minus 4, 7. And then divide both sides by the coefficient, 8, to make it a phantom 1. Phantom 1x equals 7/8. So let's check. Let me go to my calculator and check this, okay? So yep, the calculator shows us 4 parentheses 2 times 7/8 plus 1. Enter, yeah, that gives us 11. So that's a true statement. So last thing here, yeah, we'll just box these in. Right, we got 2 parts to box in. We got this, try to make that a little better. There we go. That's not a bad box for me. There we go. All right, now this word consecutive, again, I don't know that you use this every day in your conversations with buddies, but consecutive numbers are 1 unit away from another, okay, such as 1, 2, 3, right? 1, 2, 3. These are considered consecutive numbers. There'd be 3 consecutive numbers. Can you have 4 consecutive numbers? Sure you can. You can have just 2 if you need to, all right? Doesn't matter. They just have to be 1 unit away from, they're just one after another, okay? If they're odd or even numbers, they're 2 units away from each other. So odd, of course, 1, 3, 5. That'd be 3 odd numbers, consecutive odd numbers. I mean, we could go anywhere in between too, right? Like 91, 93, and 95. And you could make these negative and list them that way, but that's consecutive odd numbers. Consecutive even numbers, of course, the lowest ones, 2, 4, and 6. I mean, you can make them negative if you want, but we can go higher than that, like 2,534, 2,536. That's good. That's 2 consecutive even numbers, all right? So it's important that we know consecutive is because it's very likely you're going to see the word consecutive not only on the homework, but probably on the quiz for this unit as well, because that's the way that usually comes out, okay? So this problem says the sum of 3 consecutive integers. Integers just indicates it could be positive or negative, but we shouldn't be seeing any decimals or fractions with integers. The sum of 3 consecutive integers is 66. List the numbers from smallest to largest. Now this isn't too bad, listing the numbers from smallest to largest, because our number is positive. If it's negative, that's where a lot of students make a mistake. It's not that they've gotten the answers wrong, it's just they've listed them in the wrong order, okay? This one's positive, so we don't have to worry about that right now, although we may see one, okay? So there's a couple ways to do this, and I didn't see that this one said we had to write an equation for this. I'm still going to do it, and then I'm going to show you a little bit of a shortcut. Whichever way you do it is up to you, okay? But it says the sum of three consecutive integers. Three consecutive integers, so they're just one right after another. Now, we don't know what the smallest number is, although I will say, for me anyways, that I'm going to make x the smallest number. Could you make x the middle number? Yes, you could. Could you make it the largest number? Yes, you could. But its relationship to the other two numbers is important, and that will affect the type of equation that you write for this, okay? So, x for me is a small number, so I take my small number. Now, I'm looking at consecutive integers, which is one after another, and that's important because since this is the smallest one, x, the next number that's bigger would be one more than that. So I take x and add 1 to it. That would be the second number. The third number then, I'm going to relate to the smallest number, which is x, the smallest number, but now it's 2 away from it. So I add 2 to that. Okay, if for some reason I made x the largest number, which is okay, I would have made the smallest number x minus 2, the middle one x minus 1, and then the big number x. You'll get the same answer if you do that? Yes, you will. Yes, you will, okay? Now, I did say that it's the sum of these three, so I got to add them all together, is, so there's our equal sign, is 66. Oh, it's kind of a long equation. Maybe. I mean, I think we've seen bigger, but it'll do. All right, so this is an equation that we're going to solve, and what we want to do first is, I mean, if we needed to distribute, we would, but now all I can do is combine like terms. So there are some like terms to combine. We got this x, that's one x by the way, and then another x, and then another x. One x, two x's, three x's. So altogether, we end up with three x's on the left. And then in addition to that, we have 1, and then another 2, which would be 3. So 3x plus 3 is going to equal the 66. All right, so combining like terms, where we had 1, 2, 3, 4, 5, 6 terms. Now we've reduced it into 3 terms just by combining like terms. Now principles of equality. I'll subtract 3 from both sides, and hopefully we have this down okay, at least. So that zeroes that out. I'm going to drop my 3x. Is going to equal 66 minus 3. That's a 63. Now, if you're still doing that on your fingers, that's fine. But remember, you could use a calculator even for a calculation like that, and you shouldn't be ashamed if you need a calculator for that, okay? But now, I'm going to divide both sides by my coefficient 3 to make that a phantom 1x. And what do I get? X equals, looks like 21 on that, okay? So that means, remember, I defined x already. I said x is the smallest number. That means that my smallest number is 21. Whoops. There we go, 21. So the next consecutive integer would be 22, and then 23. All right? And you could have gone back here and said, well, what's 21 plus 1? Well, that's 22, and then 21 plus 2 is 23. That's fine if you need to do that, okay? Now, the last thing I would do to check this, not just in the equation, but I would actually check to make sure these three numbers, which are consecutive, and we know they're consecutive, but the other condition here is that they add up to 66, right? So let's go ahead and add these up. 21 plus 22 plus 23, 66. So yeah, that checks off, and now I know for sure that these are the three consecutive integers that add up to 66. Let's look at another method, and I'll just do it here in the top right, okay? So here's what we know, is that it's the sum of three consecutive integers, all right, which is 66. So what you can do is you can take the sum, which is 66, just divide it by however many integers there are, which is, in this case, 3. 66 divided by 3, and what do you get from that? 22, okay? So 22, well, what's significant about that? It's the average of the three numbers, which is the middle number. Okay, the average is going to tell you the middle number. Okay, so to figure out the smaller one, I'd go 1 down. That'd be 21, and the bigger one would be 23. So you see those three numbers, 21, 22, 23. You can use it by using averages. And since it didn't really ask for the equation, that'd be perfectly fine if you did it that way. Are you going to have to use it that way? No, it's up to you. Yeah, this one wants our algebraic equation on this one too. So yeah, we'll have to write an equation for this one. Could you use the averages to solve this one? Yeah, you could, but yeah, they're going to force us to write an equation for this one, all right? So be ready for it. And yes, we will use x for the variable. Here we go. The sum of 3 consecutive even integers, that's important, is negative 174. Now this is negative, so we got to be careful on that too. List the numbers from smallest to largest. So for me, once again, I'm going to say that x is the smallest number. Smallest number, okay? And is smallest that much more writing? It is for a math person, sorry. So here we go. X is the smallest number. Now we're looking at specifically 3 consecutive integers. So the smallest one is x. The next one would be x. Now it's bigger, but it's an even, which means it's 2 away from the smallest one, okay? So, and you could say, well, why don't you just use a different variable for the middle number? It's because we don't want 2 variables in our equations right now. Eventually we will, but not right now. The third number, which is going to be the biggest one, since it's 2 more than the middle one, should be the smallest number, but now plus 4. Okay? Because these are specifically even integers. They're 2 away from each other. So small number plus 2, the next one would be the small number plus 4. And it's the sum, so we are going to add these together, is, so that's equals negative 174. All right, so this sets up the equation, which again, for this one is its own answer, and that's okay. But it will solve the same as that last problem we just barely did. So let's look at combining some like terms. There's 1x, there's 2x's, and 3x's. So I'm just looking at the x terms, 3x's. And then we also have 2 plus 4, which is a positive 6. This will equal still negative 174. Now, principles of equality means I need to subtract 6 from both sides. And yes, that is a negative, so we got to be careful on that too. Negative 174 minus 6 will be negative 180. I zeroed out my plus 6 there, but I will drop my 3x. So now, as of right now, 3x equals negative 180. Just divide both sides by the coefficient 3, and we're done. X equals negative 60, okay? Now, I did say earlier, you got to be careful with those negative numbers because students have a tendency to be like, well, negative 60, and then negative 62, and then negative 64. Okay, you just showed, if you do that, you've just shown 2 numbers that are smaller than your smallest number. In fact, if you were to check this, it wouldn't work, right? Because negative 60 plus negative 62 plus negative 64, that would be negative 186. The negative thing is what we got to be careful about. And think about the way that we wrote that equation, right? The smallest number is negative 60. The next number would be plus 2 from that. So negative 60 plus 2, that'd be negative 58. And then even next, you'd have to add 2 more to that, which would be negative 56. And so it's important to understand, if you want bigger numbers from negatives, the negatives get smaller. Well, remember, this is 2 answers right here. So there's 1. Yeah, if by chance this problem, it said instead of even, and let's just replace this with odd. This equation does not change at all. Perimeter. So perimeter, just the distance around an object or shape. Generally, we're dealing with rectangles. You just got to add all the side lengths together. Bam. There you go. Perimeter, right? And yeah, like I said, we're usually dealing with rectangles like this one. Now, if you wanted to know, which I don't think anyone does, but like if you said that this was width to a math nerd, their head might explode. So like if you know math nerds in your life, just tell them the width is the longest side of a rectangle and just watch them freak out, okay? It's a technicality thing. I don't really care myself, okay? But I am a math nerd. It just doesn't bother me. But the length is generally the longest side of a rectangle. Area is very different than perimeter. This is not an area type problem that we're looking at. So, yeah, it looks like we got to write the equation for this one. A rectangular room is 11 meters long. We'll use x for our variable, no problem. But at least the length here is 11 meters longer than the width. And that's important right there because it gives us a comparison with width and length. That's good. Then its perimeter is 134 meters. So there we go. Is would be an equal sign for an equation. Okay, so find the dimensions Dimension of the room? Dimensions, okay. So let's go and write our equation first. Here, all right, so it's a rectangular room. And, I'll draw a picture for this one. Not that you have to draw a picture for it. But it did say that it's 11 meters longer than the width. Okay, so if I said, let's say that this is the length here, and then this is the width. Well, it said the length is 11 meters longer than the width. So if I wanted to, I could write an equation for length where it's the width, but 11 meters more than that. Okay, which means that the opposite side, because it's a rectangle, would be also the width, but plus 11. And then the bottom width here, well, it's just width. Okay? Well, why do we want everything written in terms of width? Or just with W's, width. It's because we don't want equations with two variables. We only want one variable in our equations, okay? So, what is perimeter? Let's look at perimeter. Perimeter is length plus width plus length plus width. Well, isn't it double length and width? Yeah, but I like to show all four sides. I like to see all four sides. Okay, so I write it like this. Okay, well, that has three variables: perimeter, length, and width. That's true, but we can get rid of some of them if we reread the problem, right? Rectangular room's 11 meters longer than the width. So all my L's, I've already written an equation for that. This L right here is the same L right there. I don't want L, I want W plus 11. Okay, do it then. Okay, so let's get rid of our L's and well, if I can, and replace them with W plus 11 there. Okay, so there's a W plus 11. And on this other one here, replace the L with W plus 11. There's our 11. Then it is width, and its perimeter is 134 meters. That's crucial because it just told us right there the perimeter is 134. So let's get rid of our P. And I'm glad because when I teach my 7th and 8th graders, they laugh when I say P. But 134, okay? So there we go. That's an equation that we can solve now. Is there a different way to write this equation? Yes, but like I said, I like to see all four side lengths on there. All right, now we have an equation that we're ready to solve, and we have some like terms to combine, right? There's a 1W, 2 W's, 3 W's, 4 W's. So there's 4 of these widths. And in addition to that, we got 11 and an 11 right there. That'd be 22, so plus 22 right there. So we end up with 134 equals 4 of the widths plus 22. Now, I think I've said this before, right? Sometimes we in mathematics, we change things to be what we want them to be, but without changing the values. That's what we did up here in this with the W plus 11. I didn't want to see length. I wanted to see the relationship between length and width, which is 11 more than width. Length is 11 more than width. That's what that is right there. So right now, this is reading, look, if you took 4 widths and added 22 meters, it looks like, you'd get 134 meters. Let's finish solving this. So principles of equality. I got the W's already on the right, so I'm just going to subtract 22 from both sides. And then I'll drop my 4W there, which now equals, there we go, equals 134 minus 22. I get 112. That should work out pretty good. Because now we'll divide both sides by the coefficient 4. And looks like we get 2, 2 and then 32, 8. Thank you. 28. And this is just the width. Remember, it should have said dimensions. Sorry, typing, sorry. We did get the width, and by the way, you should label that. So I'm going to write meters here. 28 meters is the width. That's one of our answers. The other answer is the length, and we know that the length is the width plus 11, so I'm going to take my width and add and just replace it with the 28 meters that we know it is now. So plus 11, and ends up being 39 meters right there. So that should be, this should be our length right here, okay? Can you check this? Yeah, now there's 2 things we need to check. We have 2 conditions that need to be met here, and that is that the length should be 11 meters longer. Is 39 11 more than 28? Yes, it is. The other condition is that the perimeter should be 134 meters. So 28 plus 39, in fact, I'll just do that in my calculator. 28 plus 39, 67 plus 28 plus 39. So let me just multiply it by 2, and that's fine. 134. So it does check off for perimeter as well, and now I know that my answers are correct. All right, here we go. Rectangular room is 7 times as long as it is wide, and its perimeter is 64 meters. Find the dimensions of the room. What's different about this one? Well, on this one, it's saying that it's 7 times as long as it is wide. Okay, so this isn't 7 more, it's 7 times, and it's important to know the difference. Because, and I'll do another drawing here as much as you probably hate it. So, right, we got length, and then we got width, but the length is 7 times the width, 7 times as long as it is wide. So that'd be 7 times the width, and of course the other side lengths would match that. There's a width, and then the other opposite side there would be 7 widths. You can put the L there if you want, but I guess it's already kind of redundant. So, what is perimeter? Perimeter is when you take length, and then plus a width, and then plus, that was kind of a sloppy W. I'll take it though. It's not my worst. Hopefully that's not surprising, but plus length plus width, okay? And now we know that the length is 7 of the width. So I don't want to see L's. I want to see 7W's. So that's what I'm going to do. This is 7.
This is what.
All right, and it did say up here that the perimeter is 64 meters, so I'm going to replace the P with 64. All right, and yep, this becomes an equation that then all we got to do is solve. And there's only like terms on the right side there. The W's, 7 W's, that'd be 8 W's, another 7 would be 15, and then 16. 16 widths. So if you took 16 of the widths, you'd have the equivalent of 64 meters on this one, all right? So what are we going to do? Just divide both sides by the coefficient 16, and that gives us phantom 1 width. 1 width then would be 4 meters. Okay, so now we know the width is 4 meters. We know that up here it said that the length was 7 times the width. So, right, the width there, I'm going to multiply it by 4. 7 times 4 is 28. 28 meters is the length, okay? So, again, there's 2 conditions on this one. Is the length 7 times the width? Yeah, 4 times 7 is 20. That's actually what we just did. Well, what was the other condition? It says that the perimeter should have been 64 meters. Well, 4 plus 28 is 32, plus 4 would be 36, plus 28, boom, 64. And now we know that we did this correct. I like this one, even though most people hate it. But here we go. A bag is filled with red and black marbles. There are 57 marbles in the bag. If there are 13 more red marbles and black marbles, find the number of red marbles and the number of black marbles in the bag. No problem, okay? So it says there's 57 marbles in the bag, right? So, I can use some color coordination. I don't know if it's super pretty, but we got red marbles and then we got black marbles, right? If I were to add these together, it says up here there's 57 total marbles in the bag. So that gives us 57 marbles right there. There's one equation just from that sentence. And I guess the previous one. Then it says if there are 19 more red marbles than black marbles. Okay, so that means that the red marbles here, so I'm using red on purpose, means you'd have to take the number of black marbles and then you'd have to add 19 to that. Okay? Could you do 19 plus B? Yes, you could. But I'm saying R is for red marbles, B for black marbles. Okay? And yes, I am trying to color coordinate this. So the red, right here in this equation, this first one, I can replace it with the other part of the expression so that this equation becomes a one variable equation, all right? Which is important, and we'll talk about other alternatives later on when we look at 2 variable equations. But for now, the red, instead of showing it as red, I'm going to show it as the black marbles plus 19 marbles, okay? So then we still got the rest of this right here, right? Hey, there's an equation, and there's only one variable. That's nice. That allows us to solve, then, that equation. So there's one black set of marbles and another black set of marbles. That'd be 2 black sets of marbles plus 19 marbles there. Just drop that down. Equals 57 marbles. So principles of equality, right? With a little bit more space. Subtract 19 from both sides. And to zero that out, Here's our 2 sets of black marbles, equals 57 minus 9 there would be 38, looks like. And then finally, since we do want the number of black marbles, we'll just divide. We don't want 2 sets of black marbles, just 1 set. We'll divide this by 2. That will give us 1 set of black marbles, which is, looks like 19. I'm just going to put marbles. If you want to go the distance and put black marbles, that's fine. But I'm already kind of trying to color coordinates, right? So that's the black marbles. Up here, for the second equation, I said that red marbles is the black marbles plus 19, but now I know the number of black marbles there is, 19 marbles. Oh, it's just plus another 19 right there for the red marbles. So the number of red marbles looks like it's 38. Again, you can put red marbles, but marbles is good. Okay? So again, we had 2 conditions on this one. The first one was that total, there should be 57 marbles, and 38 plus 19 is 57. And then there should be 19 more red marbles than black marbles. So we took the black marbles, added 19, boom, we got 38. That checks off both conditions. Red marbles is 38, black marbles 19. So we got to translate this one to an equation, and then we'll solve it. Kimberly bought a bookcase on sale for $560, which was 2/5 of the original price. What was the original price of the bookcase? We'll use X for the variable, which appears to be the original price of the bookcase. So, for this one, let's see, she's going to buy this bookcase for $560. So, total is what she's going to spend, but it is, or was, so that's the equals part right there, 2/5, there's a fraction there, 2/5 of the original price. And the original price is what we're solving for. That's the unknown part of the equation. So it's 560 equals 2/5 times x. Sorry, that 5 kind of looks like a 6, but it's a 5. So to solve this one, I'm just going to divide both sides by the coefficient. So I'll show it a different way, right? Divide by 2/5, because it doesn't matter. So there's divide by 2/5 as well. Okay, so that becomes the phantom 1. This is going to be x, which was the original price. I'll go to my calculator for this one. I'd feel more comfortable with that. So 560 divided by 2/5. Boom. Yep. Thank you. Yeah, $1,400 for that was the original price. And some of you may have thought about this in like as a percentage. Like you just know that 2/5 is 40%. That's fine too.